Hello and welcome to Families of Functions. This is our first video of the year. The way this works is that I want you to write down everything you see on the screen. If I'm working on a problem, I want you to follow along and work that out. Sometimes I have an example problem that I ask you to try and then play the video to see my answer. If you're a person that normally has notes provided to you, you can take screenshots of this along the way so that you have notes and you can always come back to this. Okay, so families of functions, we're just going to look at big picture, the different kinds of functions that we see. So we're looking at direct variation or directly proportional functions. Ones that go through the origin, which is 0, 0, that's the word we use for the origin. Ones that are directly proportional will either increase at a constant rate or they will decrease at a constant rate. So something like this is directly proportional because as one goes up, the other goes up, and it's staying the same rate. As one goes down, the other goes down, and it's staying at the same rate. You'll notice both of these have intercepts at 0, 0. They go through 0, 0. The x-intercept and the y-intercept are the same point. Another type of variation, so this would be a directly proportional. One goes up, the other goes up. Okay? Another kind of proportion is inverse variation. And what happens there is that we've got a it's decreasing at a decreasing rate. So it starts by dropping a lot, then dropping a little bit less, and then a little bit less, and a little bit less, a little bit less. This is an inverse curve. You can see there are no x-intercepts or y-intercepts. It's never actually going to touch here. We call that an asymptote. You're going to learn that later. And it's never really going to touch here. We'll call this line an asymptote. It gets close to it, but doesn't actually touch. This is called an inverse variation family of functions. Another kind you might be a little bit familiar with is called exponential. For all the COVID data that's out there and all the things we've been studying with COVID data, it is all exponential growth. It starts small and it does not grow at a constant rate. It grows at an increasing rate. So an exponential function might start very small but then increase at an increasing rate. Or this is exponential decay. It might decrease at a decreasing rate. This one looks like the inverse curve, doesn't it? Exponential functions will have a y-intercept, but they won't have an x-intercept. They won't actually cross the x-axis because, like, you can't have negative cases and you can't have negative people. So this is called an exponential curve, increasing at an increasing rate. Linear graphs. So proportional graphs are one kind of linear graph that goes through 0, 0. But as long as it has a constant rate, we would call it linear. This one doesn't go through the origin, but it's still increasing at a constant rate. Or you could have it go like this and decrease at a constant rate. As long as that rate is constant, we would call it linear. It has an x-intercept someplace here where it crosses, right about here, and that is some number and then 0. It has a y-intercept here, right? 0 something, maybe it goes up 2. So we would say the y-intercept is the point 0, 2. This x-intercept might be, let's say, negative 3, 0. That's what it would look like. Okay? Another family of functions is the quadratic family. Right? This is things that you throw up in the air and it comes back down. Or like a roller coaster, it goes down and then back up. It's both increasing and decreasing. It could have two x-intercepts like this one does. Some of them might only have one x-intercept. Maybe you got a graph that comes down and just touches one time. Or maybe it doesn't touch at all. Maybe it's up here. And this maximum or minimum point that you see like right there, that's a minimum. That's called the vertex. The last family we're going to look at is an absolute value. Remember that absolute values are these bars. Whoa, that was weird. Are these bars, something like this. And usually with absolute value, when you see that, it's making things change the distance away from 0 from negative to positive, right? Well, the same thing's kind of happening here. But the graph will be linear, and it'll go in one direction, and then it'll be linear in the other direction. So when we ask, is this increasing or is it decreasing? Well, it's both. It's decreasing until we get to here, and then it's increasing from there. So absolute value graphs, they usually look like a V, where the quadratic ones usually look like a U, right? That's the difference. Straight lines versus the curves. So the things we're going to study this year are going to fall into one of those families of functions. And we're going to spend a little bit of time with linears, a little bit of time with quadratics. You're going to see some of these absolute values along the way. But so this is a general overview, a bird's eye view of the kind of families of functions that we're going to see this year.